The short presentation is to introduce you to the GL-S family of 3-volt NOR. It's an exciting new product that dramatically changes performance that NOR delivers to systems today. Spansion's GL-S flash delivers breakthrough performance for embedded applications. Read performance has increased 45%. Programming performance has increased over 1,000%, and erase performance has increased over 650%. The GL-S is made on a 65 nanometer charge trapping technology proprietary to Spansion. It's available in industry standard packaging and industrial and automotive in-grade temperature grades. Spansion GL family of flash has been very popular in the embedded marketplace over the last 8 years. Spansion's GL-S flash, 65 nanometer based, is being rolled into production in 2011. Delivers the highest performance of any embedded NOR solution in the market. A full complement of technical support is available for new designs, as well as to enable migration of existing designs to GL-S flash. On the Spansion website, www.spansion.com, you'll find datasheets, hardware and software application migration notes, as well as low-level drivers, flash file systems, and simulation models. Many industry-leading performance enhancements are available to speed your applications and enhance the end-user experience using your products. GL-S employs a 32-byte, 15 nanosecond interpage mode read buffer. In comparison, GLN and GLP have 16-byte, 25 nanosecond read page buffers. GL-S provides 1.4x the achievable read throughput compared to GLN and GLP flash. GL-S flash employs a 512-byte write buffer. In comparison, the GLN has a 32-byte write buffer and the GLP has a 64-byte write buffer. When you use the full buffer for programming, GL-S delivers 1.5 megabyte per second sustained programming throughput. That's an 11x improvement in achievable write performance compared to GLN and GLP. GL-S delivers 655 kbyte per second erase throughput, which is 7x the achievable erase throughput of GLN and GLP. When you combine the program, erase, and read performance enhancements of GL-S, you can achieve an 80% reduction in your production-related programming expenses. Spansion has added a third method of determining embedded operation status. Besides the legacy ready busy pin and data polling methods, a new status register can be accessed with 2 simple cycles to determine the exact state of an embedded operation. The status register provides more detail than data polling or the ready busy method, and we recommend it for new designs. Your IP code and data are sensitive, and Spansion has increased the security options available to you with their GL-S family of flash. Besides the legacy security features such as the write protect pin, password and persistent non-volatile sector protection, dynamic sector protection, and custom orderable permanent lock protection, GL-S family also supports a read protection mode. In read protection mode, until a 64-byte password is provided, only the lowest sector, or the highest sector, depending on part ordered, can be read from. All other sectors are read, write, and erase protected. Spansion has consistently provided an easy migration path from GL family to GL family by relying on our universal footprint for TSOP and BGA packages. GL-S maintains that tradition. Discrete GL-S flash will be available in TSOP 56 package with the same pinout as the GLN and GLP when used in BY16 mode. These will be available with 100% matte tin solder. The discrete GL-S devices will also be available in a 9x9mm BGA package with SAC 305 solder. This particular package is 40% smaller than the 11x13mm package used in GLN and GLP devices. The S70 GL02GS stack device will use the same 11x13mm 64-ball BGA package utilized by the 90 nanometer equivalent S70 GL02GP device. When migrating to GL-S, it's important to understand the differences in power on reset and hardware reset timing. For power on reset timing, it's important to delay the first access to the flash for 300 microseconds after power application. GLN required only a 500 nanosecond delay, and GLP required a 35 microsecond delay. While this delay is significantly longer than previous generations, it's generally well within the capability of a system, and that the host generally takes much longer to come out of power on reset than flash requires. One additional characteristic of the GL-S power on and hardware reset timing is the need for a CE transition from high to low to start the first access. CE must be held high for a minimum of 20 nanoseconds prior to this initial falling edge of CE. Warm reset or hardware reset timing has changed as well. Reset pulse width can now be as short as 200 nanoseconds. However, during an embedded operation, the device still requires 35 microseconds to complete the reset operation. Some legacy features have been removed from Spansion GL-S Flash, including BY8 data bus support, unlock bypass command support, multi-sector erase command queuing support, high voltage auto select access, and high voltage accelerated programming. When migrating to GL-S Flash, if software is configured using device ID, no changes will be required. If software is configured using CFI register values, it's quite possible changes will be required. As GL-S uses CFI revision 1.5, previous generations of GL Flash use CFI revision 1.3. Some software, such as Linux, verifies the minor revision in the CFI table, and this will need to be changed to support the GL-S Flash. Patches are available on the Spansion website if that's needed. Now, the Spansion's GL-S Flash has a 512-byte write buffer. It is recommended that programming be done in 16 to 256 word increments, or 32 to 512 byte increments. Additionally, Spansion has added a blank check command to the GL-S family of Flash. This can dramatically improve performance when updating in system, because you will not have to erase a sector that doesn't have data in it when updating a large data set. Spansion is very excited to introduce the Spansion GL-S and its industry-leading performance. Our 110 nanometer GLN and 90 nanometer GLP set the mark for high-density NOR up through 2010. Beginning this year in 2011, the 65 nanometer GL-S will be the highest performing high-density NOR solution available for embedded applications. Our entire team is here to support you in this exciting transition. For questions or assistance in your next designs or design migrations to the GL-S family, visit the support section of www.spansion.com and contact our technical support team. My colleagues and I are here to help.